And what we're going to be able to do is identify vertical and horizontal translations and reflections within a function. And we're going to talk about what all of these things mean as we go through the lesson. So the following basic graphs will be used extensively in these sections. It's important to be able to sketch these from memory. All right, so very important that we memorize these, okay, that we are able to sketch. That doesn't mean that we have to perfectly draw these, but we need to know the general idea of what these look like. So our first function is the identity function, which is f of x equals x. So that means that, for example, if x equals 1, then y is equal to 1. If x equals 2, then y is equal to 2. Okay, and so on. So this is also, you could see this as y equals x. The graph of y equals x goes like this. From left to right, it goes up and it goes through the origin and is a straight line. Okay, our next one is a quadratic function. This is f of x is equal to x squared, or y is equal to x squared. Okay, this has a general shape of a U going through 0, 0, or going through our origin. Okay, the square root function, f of x equals the square root of x, or y equals the square root of x. This starts at 0, goes through 1, 1, all right, and then it has, it's almost like this parabola, the U shape, but it's turned over on its side and only one side of the parabola. Okay, this couple things to note. One is at 1, the square root, because the square root of 1 is 1, the square root of 4 is 2. So right there we have the point 4 comma 2. All right, the next one would be 9 and 3. Okay, the absolute value function. So whatever we plug in for x, it turns out to be a positive number for f of x or our y. So y is equal to the absolute value of x. So here at 1, y is positive 1. Here at negative 1, y is also positive 1. So the absolute value function has this V looking graph. Okay, this is an even function, meaning that we have symmetry over the y-axis here. Okay, we have a cubic function. F of x equals x to the third. This is y equals x to the third as well. This is an odd function. We have symmetry. We have symmetry across the origin. All right, and this goes and then levels off right here at 0 and then continues to increase after 0. So this function is always increasing. All right, the rational function, y equals 1 over x. Okay, this looks like this on this side, on the positive side when x is positive, and then it's has this sketch or this on the negative side for 1 over x. If x happened to be negative 1, then you would get negative 1. All right, and so forth. So that's why this graph has this type of structure. Okay, we'll now see how certain transformations or operations, all right, on a function changes the graph. This will give us a better idea of how to quickly sketch. That's the key word right here, is quickly sketch the graph of certain functions. So you have 3 things. You have a translation, a reflection, and a stretch. Okay, so let's define each of those things real quick. So first we have what's called a vertical translation. All right, so this is a kind of a rule that we can go back to. Outside is true. So what does that mean? So here in red we have our basic graph, or sometimes referred to as the parent function, f of x equals x squared or y equals x squared. This is in red right here. That is that graph. So you can see it goes through 0, 0. All right, and then we also have in blue, this has f of x is x squared plus 3. And what you notice is this entire graph is shifted up 3 units. Okay, so everything in this graph is shifted up 3 because of this plus 3 outside of the function. All right, the same thing for this black line here for representing f of x equals x squared minus 2. So that's showing that this graph, this is the same red graph right here, the same graph, and everything is shifted down 2 units. And then we have the same type of U-shaped structure, parabola, right? And this is shifted down because of the minus 2 outside on the end of our function. All right, so anytime you have a graph where it's at y equals f of x plus d, all right, that means that you're shifting up however many units. Okay, and if we have f of x minus, this is supposed to be a minus there in that box, all right, that means that our graph is shifted down d units. Okay, so a couple of things for the vertical translation. All right, now horizontal. Horizontal is a little different. It has a different structure to it. So it is going to be lying within parentheses. All right, so the thing to remember here is the inside lies. All right, so outside is true, inside lies. So for example, again, we have our basic function f of x is equal to x squared. That goes through 0, 0, has the U parabola shape here. All right, and this first one is our blue graph here. So let's change colors. Let's do our blue graph, and our blue graph is right here. Okay, and that graph is shifted not up or down. All right, it's actually shifted to the left 2 units. All right, and so this x plus 2 actually puts us at x equals negative 2 right here. So anytime the graph is x plus some number on the inside, all right, x plus a number on the inside, that is going to be shifted left that many units. Okay, so now let's look at the opposite. So our green here, our green function, y equals, or f of x is equal to x minus 2 squared. So I'm thinking of all of this, right? Something could be x, all right, but it's x minus 2 squared. So I'm taking this normal parabola, y equals x squared, and I'm shifting it to the right 2 units. Right? Everything gets shifted to the right. So anytime we have a minus inside the parentheses, that is going to shift our entire graph to the right that many units. Okay? So you can also have a combination of these. So my function may look like y equals, all right, f of x plus or minus c, and then plus or minus d outside of our parentheses. So numbers added or subtracted inside translate left or right, while numbers added or subtracted on the outside translate up or down. So you can draw it like that. All right, think about it like this when you're moving these functions or translating. A translation is just a movement of the function. All right, so this example, so this is my original function, f of x is equal to x squared. and then h of x equals x squared plus 3. This plus 3 represents our function being moved up 3 units. Okay, that's why we say this is a vertical shift up 3 units. Okay, a horizontal shift goes opposite because the inside lies right here. So inside the parentheses, all right, this plus 3 is actually going to go to the left 3 units. So that means that we're moving the graph of x squared, all right, to the left 3 units. Okay? Use the basic graph to sketch the following. All right, so let's just go ahead and label these. All right, example 1, example 2, example 3, and example 4. Let me space these out right here. Okay, so on example 1, all right, the graph of x squared. So again, I don't have to be perfect on these. All right, I know that the normal x squared graph looks something like this. Okay, and all I need to think about is this minus 5. What does this minus 5 do to my graph? And I remember that outside moves up or down. So this is going to shift everything on this parabola down 5 units. So instead of being here at 0, 0, we're going to be down here at -5. And we have the same exact graph. Right, everything is shifted down for this one. Okay, example 2. Let's look at it. So we have our square root, which looks like that. Okay, and we have plus 3, but plus 3 is inside the square root. It's not outside the square root out here. So this plus is going to move my square root graph. It's going to move this to the left 3 units. So we know instead of being at 0, 0, this graph is going to start at -3, and it's going to have the same shape. Okay, look at example 3. So example 3 is right here. We have a cubic, all right, a cubic graph. And we remember our cubic graph looks something like that. But this is a -2 inside the parentheses. So we can think of this as our cubic graph moving to the right 2 units. Okay, this is going to be right 2 units. So I'm going to have something that looks like that. Okay, and then lastly, number 4, I'll do this right here. Number 4, we have our absolute value function, and the plus 3 is not inside the absolute value bars, it's outside of those absolute value markings that we have. And so this is going to be not left or right, this is going to be up and down, because outside is a vertical movement or a vertical translation. So the absolute value is the graph that looks like a V. Okay, think of that as V for value, absolute value. And this is going to be moved up 3 units, and we still have our V shape. So as simple as that was just taking these original graphs that we have, seeing what their structure is, all right, and then if I had a plus 3 on the end like I did, that would just move everything up 3, and I still have the same V structure. All right, everything just gets shifted up 3 units. Okay, let's continue. So combining, all right, it is okay to combine a vertical and a horizontal shift. So for example, we may have something that's shifted down 4 units and to the right 6 units from our original function. So here we have our original function is f of x is equal to the absolute value of x, which is this graph here. Notice it's the V shape. It goes through 0, 0. And now this new function has x minus 6 inside the absolute value and minus 4 outside the absolute value. So this minus 4 tells me that we're going down 4 units. And this minus 6 tells me that we're going to the right 4 units. So you can see my graph gets moved to the right, or excuse me, it's going to the right 6 units, not 4 units. It's going to the right 6 units, and then we're going down 4 units. Right here, we're at 4, negative 4. And so now it's going to have the same V shape as the original function. We didn't change anything about the function. We just changed where it began, or where its vertex was. All right, still has the same V shape. Okay, so that is going to get us through today's learning objective, which is to determine whether or not a function is shifted up or down, or if it is shifted to the left or the right.